Hello, so for this video, we're going to learn on the completing the square method. So usually completing the square method is used for quadratic equation. So quadratic equation, you have two methods of solving the equation. So this is the general formula for quadratic equation. Okay. So the first method, it's called factorization. So the concept of the factorization method is for you to get two values of x. So as you can see here, factorization, what you need to do in this method is you separate the equation into two different brackets. So you'll have a value of x plus blah 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 and x plus blah blah blah. So that is the concept of factorization method. But for completing the square method, what you need to do is you need to change it into another form. So this is the typical quadratic form. So this is the usual form that you'll see in a quadratic equation. So what you need to do in completing the square method, you need to change it into vertex form. So this vertex form here, you will have this equation. So this equation, you will have three types of constants, which is a and h and k. So the purpose of this vertex form here is you are able to find the value of x and y. This is another application, which is one of the application of completing the square method. So completing the square method, you have its own application. So DCTS stands for completing the square. So you can find the maximum or minimum point of this graph. So how? I will show you later. So we'll just try to solve this example first, and then I'll show you the application and how to find the root using this method. So what do you need to do first? You need to make sure the quadratic equation is equals to 0. And the first step is to always make sure the coefficient of x squared, which is the value that is connected to x squared, is positive 1. So what is the coefficient of x squared? It is basically the value of a. A is the number that is connected to x, which is a constant of the x squared. So you must make sure it's positive 1 x squared. It cannot be negative because that's the requirement. So usually you can disregard the value lah if it's positive 1. So you'll just see x squared in the equation. So we make sure so it is positive 1. So therefore we can proceed with the next step. So next step, we need to remove the value of c from left hand side. So what is value of c? It is basically the constant that is not connected to any value of x. So you pick which value? It is negative 7. So therefore, we need to remove the negative 7 into right hand side. So this one, you just apply your algebra knowledge. So you move negative 7 to right hand side, so it will become positive 7. So we proceed with the next step is for us to add b over 2 square into both sides of equation. So what is the value of b? It is basically the coefficient that is connected to x, which means the value that is connected to x. So you can look at the equation from the question. The value of b would be it would be 4. Okay, so it is the number that is connected to x. So in this case it's 4. So we need to add b over 2 square to both sides. So next, you just substitute the value of b, which is 4, into the equation. So what you need to do next is you don't disturb the left hand side first. You just disturb the right hand side. You solve the right hand side. So what you need to do on the left hand side is you factorize as usual. So factorize, use the factorization method. So you just simplify the 4 over 2 square first, which is, don't need to use calculator. So 16 over 4 is 4 lah. And then right hand side you also solved. And then okay, solve the right hand side, which is 11. And then next you factorize the left hand side. So this one you just use calculator. So value of A would be positive 1, B would be positive 4, C would be positive 4. So your value of x would be negative 2. So what do you do next is you put the value into bracket, but you just leave about 2 rows for the equation. So you write x equals to negative 2 at the bottom of the equation. And then you move the negative 2 into left hand side first. So you'll have x plus 2 equals to 0. And then you just rewrite the x equals negative 2. And the x plus 2 you can put into bracket now. Don't forget to include the square. So this is your vertex form. X plus 2 square equals to 11 is your vertex form. But in this case, we're trying to find the roots of the graph. So you need to move the square into the right hand side. So what will happen if you move the square? You will have square root of 11. But you need to make sure for moving square into square root, because if you look at this example, positive 1 square and negative 1 square, you will have the same answers. So there's an uncertainty. So we are not certain with the value that we got. So we need to include positive and negative to make sure that we are certain with our answers. So after this point onwards, you will separate this equation onto two parts, which is the positive square root 11 and negative square root 11. And then after this, you just do algebra to solve this equation. So now you'll have your two different roots of this graph. So this one you just type in calculator lah. So this is how you would find the roots of quadratic equation using completing the square method. Okay, so we will apply the knowledge of CTS. So after you do all the steps until you got your vertex point, right? So you just rewrite your equation, which is the x plus 2 equals 11. That is our vertex form. So you need to move the 11 into the left hand side. So it will become negative 11 equals to 0. So now then, actually, this equation belongs to the function of fx. So what are fx? Fx are typically located on y-axis, right? If you remembered. So you can change the fx into y. So now then, how do you get the value of x and value of y for minimum and maximum point? For x, you can just find it from inside the bracket. So you'll have x plus 2 equals to 0. You'll do that first. And then you just do algebra to find the value of x, which is negative 2. And for y, you just rewrite any values, any constant that is not connected to x, which is in this case it's negative 11. So the coordinates for your maximum or minimum point would be negative 2 and negative 11. So next is, how do you know whether this graph have a minimum or maximum point? It's actually by looking at the value of ax squared. If your value of ax squared is positive, you'll have a smiley face. But if your value of x is negative, x squared, you'll have a sad face. So we just look at here. So if you have a value of positive ax squared, you'll have smiley face. So if you put the y and x axis, obviously the peak of the graph would be the minimum point. But if you have negative x squared, you will have sad face. And if you include the y and x axis, the peak of the graph, which is the hill, the peak of the graph, okay, is the maximum point. So in this graph, in this equation, in this quadratic equation, we can look at the value of a. Since the value of a is positive, therefore we know that this coordinates would be for the minimum point. So that is how you apply the CTS method and how you use CTS to solve this equation.